Okay, the goal of this video is to give everyone an introduction or an understanding of inverse trig functions. So today, I think this video might just be the inverse of sine. So if you don't, well, there's a few things we want to talk about. We always begin with, before we get to the inverse, we're going to look at sine. So if you don't remember what the graph of sine looks like, that's something you definitely want to go review. We typically draw one period that looks something like this, but keep in mind it can keep going in both directions. And when we go to find its inverse, you'll notice, well, check this out. When I come to my calculator, oh, hopefully the battery doesn't, oh, no. Okay. There's always another calculator. Okay, so I'm going to come into my calculator, and I want to be in radians, and I'm going to graph sine of x. Okay, so there's a piece of sine of x. I want to make my window square. Oh, hang on. Window, square, and let's make it that x base so we can... X base, enter. Did that do it for me? Oh, it might already be square. Okay, so one of my options is that I can sketch the inverse. And so the graph will give this for me. If I change my window, let's get a little bit more y values going on, say -10 to 10. Okay, it's going to stretch things out, but here we go. So there's my graph. When I sketch the inverse, notice the inverse, because it's not square, it looks kind of funny, but the inverse is not a function. But we always need the inverse to be a function. If you remember, when we had done something like x squared, here's our graph. If I sketch the inverse, I get something like that. However, if I have it graph just the square root of x, what that has done, okay, let's change that to square real fast. Okay, what that has done is it's restricted the domain of the original. It restricted the domain with a blue and then just found the inverse of that because it wants its inverse to be a function. So we're going to have to do something similar with sine and restrict the domain of sine so that its inverse will be a function. So if you think about it, right here, when we were looking at y equals x squared, we wanted every y value, but we only wanted the y values to show up one time. So we don't want this side, does that make sense? So my range for this graph was from 0 to infinity. So I wanted 0 to infinity, but I didn't want it to happen on this side and on that side over there. Okay, so what I'm going to do is I'm going to take this sine value. I want to notice I've got, well, a couple things I want to point out here. You gotta know what your sine graph looks like, and you've got to remember you can't ever forget the unit circle. So if you think on unit circle, here's 0, here's pi over 2, here's pi, here's 3 pi over 2, and then we get back to 2 pi. We can also, another thing to remember is that if I come this way right here, this value is negative pi over 2. So if I move if I find these two are co-terminal angles. 3 pi over 2, I've gone by going this way. Negative pi over 2, I've gone by going this way. So if we look at our curve, this is the point. My purple marker is less than ideal. Okay, this is the point 0, 0. This is the point pi over 2, 1. This is the point pi, pi 0. This is the point 3 pi over 2, negative 1. And this is the point 2 pi, 0. Okay, if that is new to you, go back. you got to know that. Well, there's the truth of it. And so this point right here would have been the point negative pi over 2, negative 1. Well, so we want to restrict the domain of this sine curve so that we get every y, but we get every y only once. So notice what we're going to do here, and it's really nice to have 0. Okay, so mathematicians kind of agreed to restrict the domain of sine to this little piece right here. That way we get every y value, but we only get every y value one time. So if you think about the unit circle, what that means is we want quadrant 4, and we want, because that's this part right here, excuse me, this part right here on my curve gives me quadrant 4, but going in the negative direction. And I want this part right here, which is quadrant 1, on my unit circle. So what we will do is we'll restrict the domain. So our new domain will just be from negative pi over 2 to pi over 2. And the range, as always, well, is from negative 1 to 1. So now when I go to find the inverse of that graph, I'm going to switch my x and my y's. Okay, so instead of negative pi over 2, negative 1, I now have negative 1 and negative pi over 2. So negative 1, negative pi over 2 down here somewhere. Negative 1, sorry, negative pi over 2. I still, 0, 0, switch them. We're still at, there it is, 0, 0. And then pi over 2, 1 becomes 1 pi over 2. So something like this, there's 1 pi over 2. So those are the 3 points that I care about in my, this is going to be the inverse of sine. And we'll talk in just a second. We can call this y equals, the inverse of sine can be written this way. Or we also have the notation arc sine. And as far as I know, those are exactly the same. So if they're not, give me a comment. But I don't know. We use them the same in both IB and in PreCal. Okay, so this is what we're graphing down here. If you think about this, this graph right here needs to reflect over the line y equals x. So if we have this line y equals x going through here, well maybe, okay, let's see. Delete. Let's graph sine of x, and let's just graph y equals x. Okay, let's change our window. Let's go from negative 2 pi to 2 pi. And then I'm going to make it square based on my x's. Oh, well that's annoying. Hang on. Sorry. Negative 3 to 6. See what happens with that. I don't know. I'm guessing. Okay, and there's that line. Well, that's nearly not. Let's zoom in a little bit more. Negative pi. Oh, I don't know what I'm doing. Negative pi to pi. And then let's see what happens here. Well, we really still can't see so well. Okay, so we need to take this piece right here. It's this curve right here, and we need to reflect it over this line. And so you'll notice this part that becomes concave, this is concave down right here. When I reflect it, it's going to end up being concave up over here. Okay, and then same idea. This is concave up, and it reflects to be concave down over here. So when I go to graph that, and I can check, I can graph inverse of sine of x. And that's going to be that green one. And you'll notice that this little piece here has been reflected over, and this little piece has been reflected. Okay, sorry it took me so long to get there, but there you go. Okay, so when I go to graph this, it looks something like that. Okay, and this is the parent function. This is all you get for arc sine or the inverse sine of x. That's it. That's the whole function. Its domain goes from negative 1 to 1. Its range goes from negative pi over 2 to pi over 2. Now, another thing that we might talk about when we look at, well, here, there's a difference. Okay, so in the past, I would ask questions like, I would say, find all theta, where sine of theta equals, say, negative 1/2. Okay, and what we would have done in the past is that we would come along and we would say, okay, well, sine is the y value. It's negative 1/2 here and here. This would be This is 7 pi over 6. This is 11 pi over 6. And so to find all of them, we want to say, okay, well, theta is equal to 7 pi over 6 plus 2 pi k, where k has to be an integer. And then I would say, okay, it's also 11 pi over 6 plus 2 pi k, where k is an element of the integers, or we like to joke and call it Kez. And so this would find all of them. So think about it. We can circle, 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 circle. Or another way to think about this is that if I graph this, my curve is going forever. Okay, and both, whoop, you can't see it. Pretend I can draw. That looks terrible, but here's my point. And so I've got this line -1/2, and you'll notice this, it's going to intersect infinitely many times. And so it's going to hit here and then here. This one would correspond to this first time there, and this one would correspond to here. And then every time, so the front of the valley and the back of the valley. So the front of the valley would be this plus 2 pi, gets me here. The back of the valley, this is a terrible picture, but hopefully this gives you an idea. The back of the valley would be this one plus 2 pi, and so forth. However, this is what we had done in the past, and I expect you still to know that and be good at that. But what I'm going to do now is I'm going to say, okay, arc sine of -1/2. Okay, well, arc sine means that you can only look at this graph right here. So there's only going to be, so the x value for this graph would be -1/2. It's going to give you just one answer. Okay, another way to think about it is that you're in the unit circle, but the only way that you can get to this -1/2 is you have to live between -pi/2 and pi/2, because that's how we restricted sine. That's the world that we're living in. Our answers are only going to be between those. Okay, so when I do that, to get to -pi/2, I have to come in the negative direction here. Well, I want to call this 11 pi over 6 because I've done that a whole lot, and I have practiced that, and I know it, and I know it, and I know it. However, 11 pi over 6 is not between -pi/2 and pi/2. Okay, so we have to get there in the negative direction, and so the answer to this, sorry, this gets a little messy, but the answer to this is -pi/6. So arc sine of -1/2 is pi/6. Another thing that I might do, because I'm not a nice person, is I might say something like, haha, I'm kidding. Well, not really. Okay, I might say something like tangent of arc sine of 4/5. Okay, so this is the new way of asking the question. The old way would be, this is the new way. The old way would have been to say something like, find tangent of theta when sine of theta equals 4/5, and then I would have in the past told you where theta needs to live. Because if you think about this on the unit circle, sine is your y value. If I have a positive y value, it's going to be in both of these two quadrants. Well, arc sine now lives in either in this quadrant 4, but the -4, getting there the negative way, and quadrant 1, getting there the positive way. Okay, so since this is positive, we don't want this other option right here. So I would have said, the old way would have been to say find tangent of theta when sine of theta equals 4/5 and 0 is less than theta is less than pi/2. Okay, that's how I would have said this exact same question before. So then this is saying the exact same thing. Find tangent of an angle, because this arc sine of something is an angle. Find tangent of an angle. Well, what angle? The angle who's got a sine value of 4/5. And so we would say, okay, since this is arc sine as a positive, we're going to quadrant 1. So this becomes opposite over hypotenuse. Yes, I picked a 3, 4, 5 triangle on purpose. No, I didn't draw it to scale. So that missing side is 3. So tangent is going to be opposite over adjacent. So that is 4/3. And that's what we would do for that type of problem. So head to the worksheet, go practice, practice, practice. It takes a little bit to wrap your head around it, but hopefully that video helped.